Graphing systems of inequalities is really something that you've already done because you've graphed linear inequalities. So before, I gave you a linear inequality and you put it on a graph. One linear inequality on each graph. Now we're going to be doing a system of linear inequalities. So two or more on the same graph. When in doubt, there's some step-by-step instructions here at the top of your page. We are going to do two examples, numbers 2 and number 3. So number 2, first we have this equation, x minus 2y is less than or equal to 4. Is that inequality currently ready to graph? No. What do we need to do? Get the y by itself. So we would subtract x on both sides. That would give us negative 2y is less than or equal to negative x plus 4. Divide by negative 2. And the one crazy thing with inequalities, when you divide by a negative, you have to flip the inequality symbol. So this becomes y is greater than or equal to negative x divided by negative 2. That'd be a positive 1/2 x minus 2. I'm going to graph that one in blue. As I've been checking some tests, I have noticed there are still some people graphing slightly incorrectly. Remember that this negative 2 is where you start on the y-axis. So from 0, 0, we are going to go down 2, and that's where we're going to start on the graph. So everyone make sure that you are starting in the correct place on the graph. A slope of 1/2 means up 1, right 2. Before you get in too much of a hurry, you need to think about, should this be a solid line or a dashed line? Solid line, because it's less than or equal to, because the line is part of the shading, it's a solid line. Thank you. And then we need to decide shade up or down. So think about greater than. Greater than means bigger, so shade up. So I'm going to write that in here, shade up. Try not to shade too dark because we are going to have to put another graph on top of this. Our next inequality is y is greater than or equal to 4. Do you notice there's no x in this inequality? So this is a ahoy. So a horizontal line at 4. Hopefully you haven't completely obscured where that is. Is this going to be a solid or a dashed line? So a solid horizontal line at 4. And we are going to shade up because it's greater than. Okay. The area that is shaded by all of the inequalities in the system is the final solution area. So our final solution area, I'm going to highlight in yellow. You would want to make it extra dark on your paper. Make it obvious where the final solution is. I really like using colored pencils for this because you can pick multiple colors, graph one of them in one color, and shade nice and lightly with that color. And then wherever the colors overlap, you can then take your pencil and shade that area in darker so it's very obvious where the solution is. All right, I'm going to randomly put a couple of points in this system, And I want you to tell me if these points are solutions or not. So you don't even have to write these in your notes, just follow along with me. Is point A a solution to the system? No, it is not shaded by anything, so it's definitely not a solution. How about point B? In order for it to be a solution to the system, it has to satisfy both inequalities. So point B satisfies the first inequality, but it doesn't satisfy the second one, so it's not a solution. How about point C? Yes, because it's on a solid line. If that green line had been dashed, then C would not be a solution. How about point D? Yes. In example 3, we now have 3 inequalities. So we have 3 things that we need to graph. And the final solution area will be the place where the graph is triple shaded. So if you have 2 inequalities, you're looking for the double shaded. 3 inequalities, you're looking for the triple shaded. What if there were 5 inequalities? Where would the final solution be? Where it was 5 times shaded. How do you say that? I don't even know. All right, our first inequality is x is greater than or equal to 1. What type of line is x equals 1? Vertical. That is a vux. So a vertical line at 1. Are we going to do a solid or dashed line? Solid because it's or equal to. And you can't shade up on a vertical line, but think about what greater than means. Greater than or equal to means the shaded stuff needs to be larger than 1. So on this number line, we are larger than 1 over to the right. So I'm going to very lightly indicate that this side is shaded. Very lightly because we are going to have to put 2 more inequalities on this graph, and I don't want to completely make this total chaos. Only minor chaos. Our next inequality is the most commonly misgraphed inequality I have ever seen. Y is greater than or equal to 0. First of all, this is a HOI. It's a horizontal line. It's a horizontal line at 0. Solid or dashed? Okay. Basically, we are retracing the x-axis. The x-axis is the line y equals 0. So, we shade up, so we're shading all y values that are bigger than 0. That would be everything up here. So right now, the solution area is the top right corner. Everyone see that so far? All right, let's put the third thing on the graph. I'm going to grab a purple or pink or something. This inequality is not currently set up for graphing. We need to subtract 4x on both sides. And then divide by 3. Do I need to switch my sign this time? No, we divided by positive 3. We don't need to switch the sign. All right. So we start at 4 on the y-axis. I'm going to make my dots super extra big so I can see them amid the chaos. A slope of negative 4/3, so down 4 over 3. Is this one going to be a dashed line or a solid line? Dashed line. And do we need to shade up or down. Down, less than, smaller, down. Okay, how many of your graphs look like total and complete chaos at the moment? Yeah, the whole thing is shaded basically. So we really need to look carefully for where it's triple shaded. So blue is shaded to the right, green is shaded up, purple is shaded kind of down diagonally. So do you see this little itty bitty triangle right here? That little itty bitty triangle is the solution area. The question is, how are we supposed to find that on our paper when we used pencil and it all looks like just a mess? Over in that white drawer unit on the side of the classroom, there's colored pencils. Feel free to borrow some colored pencils and shade in the 3 different colors, because then hopefully you'll be able to see the overlap. On a test or a quiz, I promise, if I give you a three inequality system, I will make the triangle much bigger so it's not like looking for a needle in a haystack. I'll make it a little bit more obvious. I wanted to give you the hardest possible problem as a notes problem, not an assignment or test problem.